Sig figs, important digits. We talked about multiplying with those yesterday. If you're still confused, we're going to get a lot of practice with it, so bear with me. Most of the time on Regents exam questions that I've seen, they ask you to identify the number of sig figs, or they will ask you, how many do I report to? Okay, they don't actually take off points for your final answer being rounded, but we're going to practice that in case they start doing that again. This is the rule, the multiplication divide rule. If you forget this adding, subtracting, go with this one. Least number of total sig figs. All right. Adding, subtracting is least number of decimal places. Okay, so as we go through our work today, we're going to round our final answers to correct sig figs. But it's going to be easier than what we were doing yesterday. All right. So, steps for a unit conversion. This is at the bottom of the page that has your metric table on it. Jot these down so you have them for reference later on. Once we get practicing, the more we do, it's going to become second nature. Step 1, you always want to start with your known information. Is it important to just write the number down? No, we also have to include our units. You will see why units are so important. This is one of my catchphrases that you will hear me say all throughout the school year, which is actually step number 3. Then what you're going to do, or what I like to do, and you'll see me work this out as we go through the problems, put the unit you're trying to convert to on the far right. So we're going to move from left to right. Then you're going to let your units drive your math. I will explain as we go along what I mean by that. And then the last step is the larger unit gets the number 1, the smaller unit gets the conversion factor. We'll go through and explain it in just a second. All right, so let's just jump into a problem and kind of see what all these steps kind of mean for us. So this is going to be the first piece. We're on the top of the next page in your notes. Okay, top of the next page. This is going to seem easy. You guys can probably do this math in your head, but we're going to use something we know to kind of show how this method works. So a conversion factor, guys, is just a tool that we're going to use that allows two different units to relate to one another. All right, maybe you've heard of that before. You have used them without even realizing it. So if I said quarters and a dollar, all right, how many quarters do I have? If I have $1, okay, equals 4 quarters. That's a conversion factor. All right, $1 equals 4 quarters. Okay, pretty easy. So when we do this dimensional analysis, all we're really doing is multiplying by 1 over and over and over again. Because by saying or defining that $1 equals 4 quarters, you're multiplying by the same thing. What's the only thing that's changed? The amounts are equal to each other, right? The unit is the only thing that's changed. All right, so we're trying to go from one unit to another. So the process that I go through, if we follow those rules, step 1, start with your known information. I'm going to jot down. So in this problem, we have $75. We're trying to figure out quarters. So $75, that's my starting information. That's step 1. I've written down what I'm starting with. Step 2 says put your unit you're trying to get to on the far right. So I'm trying to get to quarters. That's going to be my guide to remind me of where I need to end up. So what we're going to do is we're going to use what's called a T-chart. Okay? All we're doing, guys, with the T-chart is multiplying. Okay? We're going to multiply by fractions. So I'm just going to set up my T-chart. We can multiply by as many fractions as we need to get to our final unit, the desired unit. Okay? How can I make 75 a fraction and keep it the same? Right. So I always encourage my students, when we set up our T-chart, to put the number 1 below whatever you're starting with because it's a placeholder. Right? A lot of times I've seen in the past, the students, when they're learning this method, they will want to just put units and they'll want to put something down there. If you put something down there that's not in your original number, all right, you're going to be off. It's going to mess it up and everything's going to be confusing. So all we've done, this is my first number. I've made it into a fraction. You with me so far? Okay. So now we need to start multiplying by fractions to get to quarters. All right. So we need to use conversion factors. Do we have a conversion factor where dollars and quarters are directly related to each other? Yeah. Absolutely. We just wrote it down. Now, here comes the tricky part. This is where number 3 comes in. You've got to let your units drive your math. What I mean by that is we're trying to get to what unit here in this problem? Quarters. Do I want to stay with dollars? No. So I want to cancel dollars out. Think about fractions, guys. Where in the second box, okay, in this fraction right here, where would I put dollars so that it would cancel out? On the bottom, right? If you think back to what we were doing yesterday a little bit with our math and our units, when you have some fractions, guys, or you're dividing, you subtract exponents so they can cancel each other out. And then what unit would go on the top? Unit. Quarters. You with me so far? All I'm doing, guys, is I'm setting my units up first. If you start throwing numbers in there, you might get confused. We want to make sure that our units are going to cancel out, which we know these ones are because if it's on the top of a fraction and on the bottom, all right, they'll cancel out. You're dividing by them. And then quarters is what we're left with. Now we can just plug in the numbers. So we've set up our math problem based on our units first. This is what I mean by letting your units drive your math. Get the desired unit to be on the top of a new fraction and the ones you're trying to get rid of on the bottom. So desired on top, the ones you're trying to get rid of on the bottom. Now we can plug in our numbers. Well, look back up here to our conversion factor and match the numbers up to their appropriate unit. How many quarters do we have? 4 for every $1. Now all you got to do is do the math. So what you might see it, or maybe you want to write it this way, guys. Another way to write this instead of using a T-chart that means the same thing. $75 over 1 fraction times 4 quarters over $1. That's the same thing. I write it as a T-chart just because it's quicker than writing out the multiplication sign. But any time that you see a line in between, that means that we're just going to be multiplying our fractions. You with me? Now do the math. 1's on the bottom is not going to affect anything. 75 times 4 is what? Okay. Now, I'm sure most of you, if not all of you, already had that math done in your head, right? So this is like, why are we going through this whole process? Well, we started with an easy problem that we relate to learn the idea, the theory and the application, guys, behind this method. So this next problem that you try that's in your notes, I want you to use this method to go from 5 hours to see how many minutes are in 5 hours. I know you can all do that in your head. Work through the process. Do your best to emulate what we just did. All right, so what's step 1? Always write down what? You're starting. You're given. Guys, always write down what's given, including units. So we have 5 hours is what we're starting with. What are we trying to get to? Minutes. Put that over there on the end. Now, these are one-step problems that we've done so far. Okay? We're meaning you're going to have one new fraction that you're writing. So if we have 5 hours, what do I always put below that first one? 1, so nothing else goes down there. Now I need my new fraction. So if it helps you to just kind of write them out as fractions like I did up here, guys, go ahead and do that. That's fine. It's the same thing as the T-chart mathematically. Now, my new fraction, what unit's going to go on the bottom? What unit's going to go on the bottom? Hours. Why hours? So that it will cancel out. What unit's going to go on the top? Minutes. Now, you just got to figure out minutes to hours. How are they related? 60 over 1 here. All right, so our final answer is going to be, okay. Again, you guys all probably could do that math in your head. All right, do that whole problem. Let's take it a step further, though, and not do something that you can necessarily do in your head. Well, you probably will be able to, but that's okay. All right, convert 62 kilometers to meters. So now we're using the metric system. Okay? Again, we will not always be staying in the metric system, and you guys have been trained over and over to just move decimals. I want you to practice this method because once we get to double units, you're not going to be able to just move a decimal. All right? What's my given? All right, so I always start with that. 62 kilometers. Set up my T-chart. What goes below my first number? 1. What unit am I trying to get to? What unit's going to go on the bottom of my second fraction? My new conversion. Kilometers. On the top's going to be Now, when it comes to metric system, guys, okay, I know you probably, again, can do this in your head. The trick here is when you're converting within the metric system only. Okay, so we can see the factor that has the prefix with it gets the number 1. So when we went back here to our chart that we wrote originally, this is saying that 1 kilometer is 10 to the third of your base unit, whatever base unit you're in. So 1 kilometer equals 10 to the third meters. 1 hectometer equals 10 to the second meters. These conversion factors here should really be written like this. 1K, oh my goodness, you can tell it's a Friday, equals 10 to the third meters. 1 hectometer equals 10 to the second meters. Down here, 1 decimeter equals 10 to the minus 1 meters. Okay? So when we go to plug it in, we're going to put the number 1 with whatever one has the prefix, and then the factor, the 10 to whatever power, the exponential factor, that goes with your base unit. So this is going to be 10 to the third meters. So 62 times 10 to the third equals... Now, does that answer make sense? If we have kilometers that we're starting with and we're going to meters, which of those units is larger? Kilometers. Okay? So our answer that we're ending up with should be much larger than what we started with because we're converting to a smaller unit. That's the last question you want to ask yourself. Step 4, does my answer make sense? I want you guys to try the next few. So, first things first, write down what I'm given. 3.2 liters. I'm trying to get to decaliters. Okay? Set up my T-chart. All of the problems we've done so far are one-step problems. We will get into multi-step ones shortly. So liters we know we're going to go on the bottom, so they cancel out because they were on the top of my first fraction. Got to cancel them out. And that means decaliters will be on the top. All right. This is the hard part. Now, I promise you, this is going to get easier because we're dealing with a metric system right now, aren't we? We don't use it on a day-to-day basis. So we don't think about it, guys, the same way that other people in the rest of the world might think about it. We're going to do some English to metric conversion soon, and they are going to seem so much easier than what we're doing right now. So if you're confused, if you're like, you don't have a lot of confidence, I promise you, it's going to get easier. All right, you'll see what I mean. Now, up here on the problem, the first one, which one of our conversion factor units got the number 1? Up here, which one did we put the number 1 with? Kilometers, because it had a prefix. So guys, it's not that kilometers always gets 1. It's not that, meters never does. It's the one that has the prefix. No matter what prefix it is, when we're dealing with a unit in the metric system that has a prefix and one that does not, meaning your base unit, always put the prefix with the number 1 in front of it. So in this problem, it's going to be decaliters that gets the number 1. Because if we go back here to our chart, all of these conversion factors on the right, they're in relation to the base unit. Like I wrote out, 1 hectometer equals 10 to the second meters. 1 decimeter equals 10 to the minus 1 meters. Okay? So when you're dealing with the metric system, like we are in this conversion factor right here, put a 1 with the decimal, then whatever your exponent value is, goes with your base unit. So deca is 10 to the first. Okay? Because if you think about it, is deca bigger or smaller than liters? It's bigger, right? So our final answer should be smaller, because we're going from a smaller unit here to a larger unit. Your answer you should have is 0.32. Okay? Again, this is going to click for each one of you at a different time. Keep working through it. And when we get away from the metric system, it's going to make even more sense. I promise. Let's try the next one. 320 centimeters. We're trying to get to meters. Setting up my T-chart. Put a 1 as a placeholder so I don't put anything else down there. Now, This is why showing me your work matters so much as well, because I can give partial credit. Letting your units drive your math. I know centimeters has to go on the bottom because I want to get rid of it, which means meters will go on the top. Centimeters are gone. Now, in this second fraction, this new conversion factor that we're making, which one of those numbers is going to get the number? Which one of those units is going to get the number 1? The one with the prefix. So put a 1 with the prefix. Now, what number is associated with centimeters? Right, which is, how do we write it out exponentially? 10 to the negative second. So when we do the math there, 320 times 10 to the minus 2, we get 3.2 meters. I promise this is going to make more sense, guys, when we get away from the metric system, but we've got to be able to go between those units. Remember, on your Regents exam, show whatever worked. If this doesn't work for you guys with the metric system, do what you know. Okay? But don't give up on this method, because you're going to have to use this throughout the year. All right. How do we go between two prefix units? I believe this is example 4 in your notes. Yes? Yeah. All right. So, excuse me. Some of you guys can do this in your head in terms of figuring out, so you don't have to make it 2 steps. You're going to see me work it out as 2 steps every time. Same process. Write down what you're given. We have 17,000 milligrams. We are trying to get to kilograms in the end. Put my 1 there. Have we changed anything up with our process yet? No. Now, what do we see? We've got milligrams to kilograms. If you look on your reference table, do you have anything that directly relates milligrams to kilograms? No. You have milligrams related to grams, and you have kilograms related to grams. So we're going to make this 2 steps. We're going to go from milligrams up to grams, and then from grams to kilograms. Oh, I know. They're great. I could do so much more if I had it. All right. Follow the same method, guys. Where's milligrams going to have to go to cancel out? On the bottom. So milligrams is going to go to grams for us. Before I even plug in any numbers, I'm going to get all my units set up. So now, let's say we do 1 step. Is grams where I want to end up with? No, the beauty of this method, guys, this dimensional analysis, is we can keep adding as many of these boxes as we want, which again, what are the boxes? They're fractions. You just keep multiplying by fractions until you get to the desired unit. So now, milligrams have been canceled out. Do I want to stay with grams? Cover this part up. Ignore this right here. Okay? Let me see if I can do it this way. All right? Ignore this. Act like, okay, now this is my starting point. Same process. How do I go from grams to milligrams? Oh, I'm sorry, to kilograms. What needs to go on the bottom? Yeah, it's going to be... Let me just do this. All right. G is going to be on the bottom, so it cancels out. Kilograms are there. Now we got our units set up. Let's go back and follow our math. Isolate each box. In the box that I have boxed in red. 10 to the negative 3. Next one. Which one of those is going to get the number 1? Kilograms or grams? Kilograms, because it has a prefix. Kilograms. How many grams are in a kilogram? 10 to the what power? There you go. Now all you guys have to do is do the math. Be careful when you're multiplying by fractions. Okay? There's many different ways you can plug it in on the calculator. My encouragement to you is to do it like this, where you take top times top times top, divide by bottom, divide by bottom, divide by bottom. Now the ones, obviously, we're not going to worry about.